Okay, welcome to Algebra 2, Unit 3, Lesson 5. This lesson is going to be talking about finding the zeros of a function, graphing functions on a graphing calculator. So, a lot of these things you'll have to actually plug into a graphing calculator to help out with some of these things, but some of them are quite easy to interpret. So, really quickly, the zeros of a function. The definitions of the zeros of the function is the solutions of an equation. Or you can actually think of it as the number of times it crosses the x-axis. Okay, so that's usually the solution. So anytime you think of the zeros, think about the number of times it crosses the x-axis, and that's when y equals 0. Right? So over here, solutions when solving an equation are the x-intercepts, or when it crosses the x-axis. Okay, so now this chart right here, let's go ahead and start filling this thing out. Now fill it out with me as I talk through it. So try not jumping ahead. It'll make a lot more sense. So the degree, okay, the degree is the largest exponent. Over here, what's the largest exponent on the x? Well, considering there is no x, okay, there is no x-intercept, so the degree on the x would be a 0. Okay, now the number of zeros is equal to the number of degrees. Okay, so if the degree is 0, the number of zeros are going to be 0. Okay, now the real zeros plus the imaginary zeros equal the number of total zeros, right? So this just breaks up the style of intercepts, okay? Either they're imaginary or real, and add those two together to get this one. And again, degrees equals zeros. So in this one right here, in a linear function, first thing you do is quickly just look at the degree, which is the largest exponent. The exponent is a 1, so I put a 1 there. That means I've got a degree of 1. That means I know it crosses the x-axis one time, or the number of zeros is 1. Okay? Well, now I have to decide, is that 1, is it going to be a real 0 or an imaginary? Well, if I draw the line, it crosses right there on that graph, so I've got 1 real 0. Okay? In this quadratic function, look at it. The largest exponent is a 2, so I put the degree of 2. Therefore, I know I've got 2 real zeros. Okay? I'm sorry, 2 zeros, 2 times it crosses the x-axis. And I graph this function. I can just plug this into my graphing calculator, and that's why you need the graphing calculator. Plug it in, and you've got it crossing here and here. So you can see it crossing the x-axis, therefore it's a real 0, and you don't have an imaginary because 0 plus 2 is the 2 right there. Okay? Again, plug this cubic function into your graphing calculator, and you get a graph that looks like this. Okay? So the degree is a 3 right there. Therefore, I've got 3 zeros. I don't know if they're real or imaginary. Once I graph it, I can see it crosses here, here, and here. If I can visually see it crossing, those are 3 real zeros and no imaginary. Okay. Quadratic function, or sorry, quartic function. Okay, I've got a degree of 4 looking across. That's the biggest exponent. I put a 4 here. That means I know I've got 4 real zeros. 4 zeros. Now I got to determine what combination are real and imaginary. Again, I plug this in, and I get this, right? This one right here, when it touches the x-axis right there, that's considered a double 0. Okay, so that's 1, 2, 3, 4. 4 real zeros and 0 imaginary zeros. Now you're like, okay, I can't figure this thing out yet. Okay, if you do this function, plug this into your graphing calculator. All right, you plug this in, you know that the degree is a 5, so I put a 5 there. I know I've got the number of times it should cross the x-axis, or the number of zeros is 5. Right? When I graph this thing in, I get it crosses here, crosses here, crosses here. Well, I can only see it crossing 3 times. So I put a 3 here. Therefore, I have to have 2 imaginary, because 2 plus 3 gives me the total number of zeros, which is equal to the degree. All right? Let's go ahead and flip this over and talk about the next piece. Okay? The degree of an equation is the biggest exponent of all the terms. Okay? The number of solutions is the same as the degree, and the number of zeros, same as we fill out on the chart on the other day. On the other side. Okay, the real zeros is the x-intercepts, the ones that you can see. You zoom out of the function or zoom in, and you can see the number of times it crosses the x-axis. Those are the real zeros. The imaginary zeros is the degree minus the number of real zeros. Okay, so let's look at this. Plugging this cubic function. I know it's a cubic because the degree is a 3. Degree is a 3, that means I have got the number of zeros is 3. Well, when I plug this into the calculator, I can visually see that it only crosses the x-axis one time. But I know that the real plus the imaginary has to equal the total number of zeros. So I've got one real zero, two imaginary zeros, and if I trace the function, the real zero rounded to the hundredth is about -1. Okay? In this quadratic function, okay, I know it's a 2. The degree is a 2. It's a quadratic function. The number of zeros should be a 2, but this graph is shifted up. It's a U-shaped graph, shifted 1 point above the x-axis. So it never crosses the x-axis, but I know I've got to have two answers, correct? So the real zeros is none. It doesn't cross the x-axis visually. Therefore, I must have two imaginary answers. Okay, so no real zeros, so it says none. So 0, 0 plus 2 is equal to the 2 right there. Okay, in this quadratic function, okay, again, I have 2, the degree is 2, the number of zeros is 2. This one I can see it visually crossing the x-axis 2 times. Okay, first time here at -4.19, and the second time at 1.19. Again, you can trace the graph, zoom in and just kind of move it around, and you can see that it's pretty much close to this. All right, the next part, determine the solutions of the function looking at this graph right here. Okay, so find the x-coordinates that would graph the curve in each solution. Well, to determine f of x equals 0, well, f of x, you can always replace f of x equal to y. So where is y equal to 0? Well, y is equal to 0 on this line right here, right? The graph is equal to 0 at this point right here, this point, this point, and this point. You can say f of x is equal to 0, or you can say the solutions or the 0. So we've got zeros at, or the x-intercepts at -3, -1, 1, and 2. -3, -1, and 2, right there. Okay. Well, where's the graph? Determine when the graph is greater than 0. Well, it's greater than 0 here, it's greater than 0 right there, and it's greater than 0 right there. Okay, so it's above the x-axis. Okay, and now when we write the solution, we write it like this: draw our bracket, x, draw the bar. Okay, and you say it's the answer is coming here. It's above 0 at x greater than, sorry, less than -3, because for all x is less than -3, the graph is going up. Okay. It's also greater than 0 between -1 and 1. Put -1 and 1 there, x there. Now, I don't put less than or equal to right here because I want it greater than 0, not greater than or equal to 0. So therefore, these signs also cannot have an equal sign. And finally, the graph is above the x-axis also right there. So greater than 2. Okay, and not greater than equal to 2 because I don't want it equal to 0. I want it greater than 0. Well, on this part, it's asking when is the graph below the x-axis? Well, it's below between these 2 points and below between these 2 points. So it's between -3 and -1. Okay, and again, make the symbols less than, okay, instead of less than or equal to, because I want the answers less than 0, not less than or equal to 0. Okay, and again, it's also below the x-axis between 1 and 2. Between 1 and 2, right there. All right. Graphs of polynomial functions. Okay. It says, this is actually a pretty easy one. It says f of 2 is equal to -5, f of 5 is equal to 3, f of 8 is equal to 10. Okay, well, I just wrote this out right there, same thing. And when writing it like this, I can take this and change it to coordinates. Well, you know, that's your x input value, and that's your y output value. Well, that's your x and y. X, y, x, y, x, y, x, y. So all I simply do is plot those 3 points on here. I plotted them here. That's your 2, -5, 2, -5. Then I've got the 5, 3. Go over 5 up 3. Okay. And then I've got it at 8, 10. Plot it there. And I just go ahead and take my straight edge and draw a line straight through all of them. Well, it crosses the x-axis right here. Okay. So plot the points and find where the line crosses the x-axis or the intercept between which two of the given points. Well, it crosses between this point and this point, right? This point has the x value of 2, and this point has the x value of 5. So it crosses between 2 and 5. Right? Well, and don't worry about this part. This is not a part of the lesson. If you're missing any part of this on your notes, please download the information from Blackboard. Right? If you have any questions, come see me tomorrow and we'll be able to answer them. Take care and have a good day.